All right, algebra students, in this lesson we're going to be looking at matrices and something called determinants. So we're going to find or evaluate the determinants of a couple of 2x2 matrices and a couple of 3x3 matrices. So first of all, as the notes say here, associated with each square matrix, meaning it's 2x2, 3x3, 4x4, etc., is some real number called its determinant. The determinant of a matrix A is denoted a couple ways. You might see DET for determinant of A, or you might see what looks like absolute value bars. I like this symbol in that it just helps us give an idea. If I have a matrix, it's a 2x2 matrix or a 3x3 matrix, and I wanted to assign one particular value to that matrix, that's what the determinant is in a way. So how do you find a determinant of a 2x2 matrix? To find the determinant of a 2x2 matrix, you're going to find the product of the diagonals. So A times D would be the product that I would take first. I'd find the difference of the products of the diagonals. So I find this first diagonal going down from left to right. Well, that's A times D, whatever those elements happen to be, minus the other diagonal, C times B. I do that, I get a number, that's my determinant. That's pretty simple stuff. So I'm going to evaluate this determinant of a 2x2 matrix right here. I would take the diagonal here, so 5 times negative 4, and again, just to write it like you see up there, 5 times negative 4 is negative 20. And then I'm going to subtract the other diagonal. Well, that's 4 times negative 2. 4 times negative 2 is negative 8. I'll put in parentheses to remind us, hey, we're subtracting a negative number here. So last step, negative 20 minus negative 8 is really like having plus 8, which means our answer would be negative 12. That's our determinant. That's the value of that matrix. Try with another one. 3 times negative 3 is going to be negative 9 minus the other diagonal. Use a different color. Negative 2 times negative 5, well, that's positive 10. And negative 9 minus 10 is negative 19. There's another determinant for us. And maybe we'll throw some fractions your way just to test your knowledge here. Let's take 5 times 1/2 first of all. Pick a color. 5 times 1/2 is 5/2. And the other diagonal is 6 times 2/3. 6 times 2/3, 6 times 2 is 12. Divided by 3 is 4. So we've got a 4. Remember, we're subtracting these things. 5/2 minus 4. Let's change 4 so it has a common denominator. So it'll be the same as 8/2. So we've got 5/2 minus 8/2. And that equals negative 3/2. So that'd be our determinant. So we found 3 determinants for 2x2 matrices in a hurry. It's a pretty simple deal. Now when we get to a 3x3 matrix, there's a little bit more work involved. There's a couple of ways to do this. The method that I'm going to show you works just fine for working it out by hand. There's another method called expansion by minors that you might use at some point if you work with vectors in a physics or pre-calculus or calculus type course. So I'll save that for future. For now, we'll go with this method for finding the determinant of a 3x3 matrix. Step 1, we rewrite the first 2 columns to the right of the determinant, or the right of our original matrix. So you'll notice here we've got A, B, C, D, E, F, G, H, I, and they've got the same matrix, but then all of a sudden column 1 has been rewritten over here. ADG was here, ADG is here. BEH, column 2, is now written out here, BEH. Then what happens, you find the diagonals going down, 3 of them, starting at top left. So I go 1, 2, 3. I find all 3 of those diagonal products, add them together. Do the same going from bottom left to top right. 1, 2, 3 diagonals, find their products and add them together. And then I find the difference of those 2 sums. So diagonals going down minus diagonals going up. Okay, I'll show you that with some numbers. So first of all, I rewrite the first 2 columns outside of the matrix. So 5, 4, 1, negative 1, 0, and negative 2. Now I find these diagonal products. So some of this can be done in the head. Again, you got to be really careful when you're multiplying to not make mistakes, because there's a lot of opportunity for error here. So this first diagonal is 5 times 0 times negative 5. Well, that's going to be 0. Anything times 0 is 0. my next diagonal product. Negative 1 times 2 times 1 is going to be negative 2. My next diagonal product, 3 times 4 times negative 2, that's 12 times negative 2, that's going to be negative 24. Okay, so those would be my diagonals going down. I'm going to add them together. That's one thing. Then I find the diagonals going up. 1 times 0 times 3, 0. Next one, negative 2 times 5. It's starting to get a little messy, but we'll handle it. It's going to be negative 20. And then the final diagonal going up, negative 5 times 4 times negative 1 is going to be positive 20, interestingly enough. So I find these two sums, a blue sum and a red sum, and I find the difference between them. The blues add up to negative 26. The reds, 0 minus 20 plus 20, well, that's 0. So I'm going to take negative 26 minus 0, which is obviously negative 26. So there would be the value of my determinant for this 3x3 matrix. Now, that's kind of a lot of work, and again, diagonals and multiplying is not the end of the world. It took us maybe a minute or so. Might take a little bit longer if you're not great with multiplication. The nice thing is that your calculator with matrices, once again, is very, very good, especially when it comes to determinants. So here's us finding the determinant of a 3x3 matrix on a graphing calculator. First of all, we're going to go to, we're going to go to our matrix menu. So right above the x to the negative first, the inverse key is matrix. So I go to the matrix menu, and all my matrices currently have nothing in them, so I need to edit my matrices. So I go to the edit menu, hit enter on matrix A. I'll make a 3x3 matrix, so you'll notice how the matrix changes. I just fill in the elements as I go. Row 1 is 3, 2, 9. Row 2, 0, 1, negative 4. Row 3, 5, negative 1, and 2. So there's my 3x3 matrix all ready to go. When you're done entering the matrix, the easiest way I've found is just to quit and go back to the main screen, because now I'm going to do stuff with that matrix. Go to matrix again. Before we pick out matrix A, we're going to go to the math menu. The first option in the matrix math menu is right here, DET. That stands for determinant. I'm going to choose that option, and then I'm going to tell it which matrix we are going to take the determinant of. So go back to the matrix menu, and now the names menu, that's where I pick out the actual matrix that I'm going to use. I want the determinant of matrix A because that's where I enter my data. I'll pick matrix A, close parentheses, don't really have to, but I like to do that to be thorough. Hit enter, there's my determinant, negative 91, which was a little bit simpler than writing out the next, first two columns and finding all these diagonals and adding them and then subtracting and figuring out. You could type the whole thing into your calculator. It's pretty solid. You could do the same thing for a 2x2 matrix even. Now 2x2, that's pretty easy, just multiply and subtract, but if you wanted to type it in because you really love your calculator, be my guest. One other thing we're going to look at here with determinants. As a neat formula that if you want to find the area of a triangle, 1/2 base times height is your formula for finding the area of a triangle. Well, if you were given, let's say, 3 coordinates that represented the vertices of a triangle, you could use a matrix and a determinant to find the area, which is a pretty neat thing. Formula looks like this. I take plus or minus 1/2, I'll talk about that in a second, times the determinant of x1, y1, 1. x1 and y1, x1, y1, this would be one of the points that is a vertex of that triangle. So I take the 3 vertices, x's go in column 1, y's go in column 2, 1's go in column 3. Key thing there to make it a square matrix. I find the determinant of that matrix, and then I cut it in half. The plus or minus is simply there because I need to make it positive. Area is positive. Area is never negative. So I've got, if I had a negative determinant, well, multiply by negative half to make it positive. If I have a positive determinant, multiply by positive half to keep it positive. Make sense? So here's how I would set it up. I'd find the area of this triangle with the given vertices. All right. So I'm going to set up a nice 3x3 matrix. And I'll use just the open bars because I know I'm finding a determinant. So for me, I'll go -1, 2, and a 1. That represents this point. And then a 3, -1, and a 1. And then a 2, and a -3, and a 1. I'm going to find that determinant, okay? And again, I would type that in my calculator, come up with a determinant, and then I would cut it in half, okay? And I would cut it in half and make it positive. That's about it. That would be my area. And again, I'll let you type that in and figure that out just to save some time in the video. But that's using or finding determinants of a 2x2 matrix and a 3x3 matrix, and using determinants of a 3x3 matrix to find the area of a triangle.